Hello everyone, welcome to the entry app. So today we are going to discuss the GATE paper for computer science, GATE 2022. Okay, so let's start. So which type of problem they ask in GATE or like that? So continue in this manner. Just wait. So just we start the first problem. So which type of problem they ask here? Okay. So this is one of the TOC problem is there. So what is the problem here? Which one of the following regular expression correctly represent the language of the finite automata given below? So this is a finite automata is given already. Okay, this one. This is one of the TOC problem is there. So this is a finite automata is given here. So which one of the following here? So there are four regular expressions are given here. So which regular expression is given is like a b star b a b star plus b a star a b a star. B is a b star b whole star a b star plus b a star and b a star. C is what here? A b star b plus b a star a whole star a star plus b star. And D b a b a star a plus a b star b whole star and a b star here plus b a star. This how so four options are given here. Four options are given. So here, which of the following regular expression? Which of the following regular expression represent the correctly? Okay, correctly represent the. So here the what is the concept here? The minimum string concept here. So take the minimum string. After that, next minimum, next minimum. If minimum string is accepted here, then no problem is at all. Okay, so let us start with option A. Okay. So option A is what here? In option A, we are taking minimum strings like A, B, A. Okay, A, B, A. Here minimum string is A, B, A, and here minimum string is B, A, B, A. Okay. So start is like this is A, B, okay, and A accepted here. Okay, no problem at all. Clear. Then here B, okay, after A, okay, after B, okay. But here here minimum string like A, B is accepted here. In option A, okay, in this finite automata, minimum string AB is accepted. AB is accepted here, okay. AB is, this is A and B. AB accepted here, but AB is not generated by the option A. AB string is not generated by the option A, so it is wrong. Okay. So if any automata accept any language, then that language must be generated by the that regular expression. But here AB is accepted here, but so A and B is the final state here. AB accepted here, but AB is not generated by A. Got it? Because it minimum string is like A, B, A here, and here minimum is B, A here. So AB is not generated by the option A. Like B option B is what? In option B, minimum string is A here. Okay. A is accepted here. Here B is accepted here. Again, next, like A. Here in option B, A, B. Okay. A, B. Okay. After that, A is accepted here. In option B, again, same problem is there. Okay. What is the same problem here? Here A, B, B accepted here. A, B, B accepted. After A is not necessary. In option B, okay. In option B, if you see the like that, A, B, B accepted here. In automata, A, any number of B accepted here. But here A, B, B taken here, but A is compulsory here. A is a compulsory here. A is not compulsory. Okay. So in B, option B, A is a compulsory here because A, B, B accepted here, but in B, A is compulsory here, so we don't take here. B is wrong. B is wrong here. Okay. Now, what is the C? Like take C is what? Here, whole star is given. Okay. Here, whole star is given. Whole star is minimum epsilon x. Here, x in a C, epsilon is generated here, but epsilon is not accepted here. Epsilon is accepted. Okay. Epsilon is starting and final both are same like that. You say here epsilon is accepted here. Here epsilon is accepted here, but here epsilon is not accepted here. Okay. So in C, epsilon is generated, but the epsilon is not accepted by the finite automata. So C is also wrong. C is also wrong. C is also wrong. Now D option is there. In a D option, A B is accepted here. Here you are taking like a this one is a or total epsilon. A B is accepted here. A B accepted. Any number of B like A B B B accepted here. Okay. Epsilon is not generated in D, so it's not accepted here. Minimum is A accepted. A is there. A is accepted here. Minimum is A, B. B is accepted here. Okay. So everything is accepted which are given in the D. So option D is the correct one. So option D is the correct one. Option D is the correct one. Got it? So whatever accepted by the finite automata, that will be given in the regular expression, or vice versa. Whatever we are given in the regular expression, that must be accepted by the finite automata. Clear? So in option question number 1 is one of the TSC problem here. So answer is what? D. D is the correct choice. D is the correct choice. Okay. Let's see another problem. So what is the another problem is there? So one of the TSC problem is there. Let's see this. So which of the following is true here? Question number 2 here. Which of the following is true? Okay. So true statement is there. So option A is the LALR, the LALR1 parser, the LLR parser for a grammar, G G cannot have RR conflict, if the LR1 means LR1 parser for G does not have RR conflict. B, symbol table is accessed only during the lexical analysis phase. Okay. Third statement is data flow analysis is necessary for runtime management. And D1 is, you see the D is LR1 parsing is sufficient for DCFL, domestic contextual language. Okay, so let's see this one. The LLR1 parser for a grammar G cannot have RR conflict if the LR1 parser for G does not have RR conflict. Not necessarily, it's false one. Okay, if LR1 parser does not having RR conflict, then after merging there may be LLR1 parser having RR conflict. So option is wrong. Definitely wrong it is. Okay. So if we, so what is the conclusion here? So if LR1 not having RR conflict, not RR, then after merging, then LLR having also, LLR may be or may not be, LLR having RR sometimes or not, maybe or may not be RR conflict, reducibility conflict. Option statement 1 is absolutely false. Option 1 is false. Okay. The LLR marker may have RR conflict for all G also. Okay. If CLR1 not having, but in LLR the common states will be merging. Okay. After merging, definitely there may be RR conflict also. Not always or always. We can't say anything like that. Maybe having RR conflict. So statement 1 is false. Okay. So second one is a symbol table is accessed only during is a false one. Symbol table is accessed by all phases of the compiler. Okay, symbol table is accessed only during lexical. Is definitely false. Symbol table is accessed by the all phases of the compiler. It's a false one. Third one is a data flow analysis is necessary for runtime management. Is a false one. Again, this false one because data flow analysis is used for the control flow graph. Data flow analysis is used in control flow graph for code optimization. Okay, you use code optimization. So data flow analysis is used in the control flow graph for the code optimization, not runtime and is a false one. And D is a LR1 parsing is sufficient for DCFL. Yes, correct one. LR1 parsing is sufficient for DCFL is correct one. So D is the correct one. Okay. Now next one is In a relational model, which one of the following statement is true? Which one is true here? Okay. So either one of the DBMS problem is there in a relational model. Which one is true here? So here option A is a relation with only two attributes. Only two attributes. A relation with only two attributes is always in BCNF. B, if all attributes of a relation are prime attributes, then the relation is in BCNF. Okay. C1 is every relation has at least one non-prime attribute. Every relation has at least one non-prime attribute. D, BCNF decomposition preserve functional dependency. Okay, so let's see this one. There are four options are there. So a relation with the two attributes is always in BCNF. Yes, correct one. A relation with the two attributes always in BCNF. Correct. This is one. First one is true. Okay. How? Like suppose that like A tends to B is a BCNF. Okay. Like a B tends to A is a BCNF. So suppose that this is a relation R A B here. Okay. So here BCNF here. Okay. So A tends to B, tends to A is a BCNF. So it is correct one. So A relation with only two attributes is always in BCNF. It's correct one. Okay. Then second one is if all attributes of a relation are prime attribute, then our relation is BCNF. Okay. Is a false one. If all prime attribute, okay, if all prime attribute are then relation also is 3NF. If all are prime attribute, all attribute of relation are prime attribute, then it is in not in a BCNF, it is in a 3NF only. So it's a false one. So B is a false one. Okay. If all attributes are not BCNF, it is in 3NF only. Okay. Next one is every relation has at least one non-prime attribute. Every relation has is not necessary. Not mandatory of at least one non-prime attribute in RTMS level. Not necessary. Okay, it's not mandatory here. And D1 is a BCNF decomposition preserves function depend not necessary. Okay. Not every relation can decompose into BCNF with a dependency preserving, not necessary. So option A is the correct one. Okay, so option A is the correct one. Okay, with the two attributes, all other false statements are not necessary. Okay, if all prime attributes are there, then relation in 3NF, not in BCNF. At least one non-prime is not necessary. Okay, BCNF decompose preserve function dependency not necessary. Already seen in the DBMS like function dependency. Okay. Now next one is so consider the problem of reversing a single linked list. To take an example here. So what is the example here? Okay. So here given the linked list is given. So linked list is given like that. So the next problem is there. So one of the data structure problem. null pointer is there, and the reverse linked list is should like this, uh, this one. Okay, this one is a head node here. So this is a reverse linked list. Okay. So here, which one of the following statement true about the time complexity of algorithm that solve the above problem in a constant space? Okay. So there are the options are there. So what is the option here? Option A is the best algorithm. The best algorithm for the problem takes theta of n time, theta of time m time in the worst case. B, the best algorithm for the problem takes theta of n log n time in worst case. Okay. C is there. The best algorithm for the problem takes theta of n square time in the worst case. And D, it is not possible to reverse a singly linked list in constant space. Okay, so let's see this one. So here reverse of the linked list in constant space. So in the best algorithm is a theta of n time. We can solve this. There are one for loop is there, and there are three statements are there. So best time algorithm for the theta of n time, the worst case. Okay. So in order of n time, we can transfer, we can reverse the linked list. Okay, the well-known, very well-known problem here. Okay, so it's not a big problem is there. Next one is which one of the following which one of the following facility facilitates transfer of bulk data from hard disk to from hard disk to main memory with the highest throughput, with the highest throughput. Okay, if we are, so there are four options are there. The first one is based DMA based IO transfer. B, interrupt driven IO transfer. Okay. C, polling based IO transfer. And D, programmed IO transfer. So here, what is this? bulk amount of data. So bulk amount of data, if you want to transfer, if you want to transfer, then we are using DMA based DMA modules. Okay. So in a DMA, bulk amount of data will be transferred from the secondary memory to main memory without the involvement of CPU. There is no involvement of the CPU. Okay. So direct DMA means direct memory access. So we can directly access the memory from the secondary memory, main memory. Clear is there? So next one is next one is so here let R1 and R2 at R1 and R2 at R1 R2 be two 4-bit registers that store numbers in 2's complement form. For the operation R1 plus R2, which one of the following values of R1 and R2 gives an arithmetic overflow. Okay, option A, R1 is 1011 and R2 is 1110. B, R1 is 1100 and R2 is 1010. C, R1 is 0011 and R2 is 0100. And D is R1 is 1001 and R2 is 1111. This one. So there are both the numbers are in 2's complement format. 2's complement format is there. Okay. So the range of 2's complement format is okay. So both the numbers are stored in the 2's complement format. Both the numbers are stored in the 2's complement format here. Whose complement format here. Okay. So here register size is 4 bits only. Here 4-bit register is there. Okay. So the range of 2's complement 4-bit number is n bit number is like minus 2 raised to power n minus 1 2 plus 2 raised to power n minus 1 minus 1 here. So here 4-bit range is what? Minus 8 2 plus 7 here. Minus 8 2 plus 7 here. Okay. So minus, if any one of the number out of the minus 8 2 plus 7, then that they definitely overflow will occur. Okay. Let's see this one. Okay. So like first one is option R1 is what is 1011 and R2 is what here 1110. So the actual number is what here? So let's see this. What is the actual number here? Because one is sign bit is there, so we convert to 2's complement number. MSB is 1, then the number is negative. So to calculate the actual value, we have to 2's complement here. So here 0 to 1 becomes 0, 0 becomes 1, 1 becomes 0, 0, 1 becomes 0, and add 1 here 0, 1, 0, 1. So here minus 0, 1, 0, 1 here. So it is a minus 5. It is minus 5. Okay. And What is this year? This one is 0, 0, 0, 1, then 180 years. So 0, 0, 1 year. 0, 0, 1, 0 years. So here minus 0, 0, 1, 0 years. So it is minus 2 years. So here minus 5 minus 2 is minus 7 years. And minus 7 comes in the category of because is this one. Okay, in this category. Here minus 8, minus 7, minus 6, minus 5, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 up to 7. So here minus 7 comes in the category. So this one is a not overflow. This one is a not an overflow. Okay. So here not overflow here. So it's not an answer. Not overflow is there. Not overflow is there. No. Next one is option B is what? R1 is what? 1100 and R2 is 1010. Again MSB is 1, so we have to convert in the 2's complement format. So what is here? Like a here minus 0100 is 2's complement, so it is a minus 4 here, and this one is a 0110, it is a minus 6 here. So what is the minus 10? So minus 10 is there, so minus 10 is not in this range here. Minus 10 is not in this range, so definitely it will create overflow. So it will create overflow here. So what is the answer here? B is the correct answer. So if any one of the number does not occur in the range of the 2's complement, then definitely overflow will occur. Overflow will occur. Clear? So this is one of the digital problem is there. Next one is this is one of the best problems, operating system problem. So next one is so consider the following three threads executing on a single processor. You are using binary semaphore here, wait and signal here. So the threads can be contexted in any order at any point of time. So here threads is like T1 is there, T1, T2, T3 here. So while true, wait on S3. Okay, print C is given on signal on S2. So here while true, wait on S1, print B, signal on S3. दूध लिया while true, wait on S2, print A, signal on S1. Okay, so here there are three threads are given. Okay, the synchronization problem is there. Three threads are given. Okay, and wait and signal operation are executed. So what is the problem here? So problem is there, which initialization of the semaphore, would print the sequence BCA 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 BCA. This one. Okay. So let's see this one.
Hello. Raki? Hey Raki, तेरे ईयरफोन दिया नहीं मन. So here, let's see this one. Oh, जो चार्ज हो रही है मेरे. वीडियो हो जाती. और क्या लगा लो तो बोल यार वायरलेस. तो वायरलेस मुझे क्या है? लगा लगी मैं. हाँ बिल्कुल. अच्छा. आवाज क्या ले मैंने क्या बड़ा आवाज आ रही है मेरी. तो वायरलेस ला देगा. ऑन कर दिया तो. ऑन किया. वो जेड चार्ज आ रही है. बोल्ट जेड चार्ज. ऑन कर दी ना. वो तेरे से क्यों? हाँ. थोड़ी सी ना सही से क्यों? बोल्ट. लेफ्ट राइट बोल जाए. अरे जरा. इनका दोबारा स्किन देखा. करने वाली नहीं आवाज. तुम बता करने जा रहे थे.
और उतार दो. So here, which initialization of the shower would result BCA BCA? They are shown in infinite sequence of time. So option A is like S1 is 1, S2 is 1, S3 is 1. B is S1 is 1, S2 is 1, S3 is 0. C, S1 is 1, S2 is 0, S3 is 0. D, S1 is 0, S2 is 1, S3 is 1. Okay. So here required output is there. So try with option 1 like that. So what is the option 1 here? So here 1 1 1 is there. Okay, 1 1 1 is there. So if you start like this, S1 is 1. Okay, if you start 1 here, so here S2 1 and S1 1 and S3 both are 1. So if you try like this one is 1, then they print C also, because S1 here 1, S2 1 and S3 1. So if three are all three are 1, then T1 can come at any point of time. So suppose that T1 comes first here. So here C will be printed, but C is not a desired output. First of all, B will be printed. So until B is printed, T1 and T3 must be blocked. T1 and T3 must be blocked here. First of all, T2 finish the execution. After that, T1. Then after that, T3 here. That is not possible because here all values are 1. So T3 can come here first. So A will be printed, but not A. First of all, we want B only. So A is false. So option A is false here. Now B, what is the B here? Here S1, S2 here. 1 year again. S1, S2 1 year. So here again there is some problem here. Here. So S1 is 1, S2 is 1, S3 is 0. So suppose that here S1 is 1, S2 is 1. So if S2 comes first, if T3 comes first, and wait on S2 becomes 0 and printed A. So because preemption is there, at any point of time preemption can occur. So is it not possible to print the B, C in this order? So B is again false. Option B is false here. Now C is the correct one. Why? S1 0, S2 0, S3 0. And D same problem here, 2 ones are not possible. So like see this one. What is C here? So here S1 is 1. S1 is 1 here, S2 is 0, and S3 is 0 here. So S1 is 1 only. So here S1 on 1, then wait on 1 is 0, then B will be printed in this. So after that, signal S3. Then S3 awoke. This one is awoke. Then S3 awoke, then after that print C. So after completing B, it gives the signal on S3, then it becomes 0 to 1, and after 1 to 0, then print C here. Or it gives signal to S2, then so in option C, so we can put print the BC in the infinite sequence of time. So correct answer is A. C is the correct one. C is the correct one. Now next one is so next one is, so what is the next here? Consider the two statement with the respect to matrices. What the matrix says? A m into n, B n into m, C n into n, and D n into n. A m into n, B n into m, C n into n, D n into n. Statement 1 is trace of AB is same as a trace of BA. And statement 2 is what? Trace of CD is the same as a trace of DC. So where was the TR? TR represents trace of a matrix. Trace of a matrix. Trace of a matrix following holds. Okay. So here both are the correct here. Trace of AB same as trace of BA. Trace of CD same as trace of BA. So both of these statements are correct. There are 4 options are there given. Statement 1 is correct, but 2 is wrong. 1 is wrong, 2 is correct. Both correct, both wrong. So C is correct one. Both are correct one. Okay, both are correct. Now next one is. So next one is there. There is a C program is there. Int main int x equals to 1. Z is array is there. So in 10, 11. And this one. Okay, so this one is the problem. So let us start here. Here x is 1. Okay, now x is 1. Okay, start. Let's suppose that x is 1 here, and there is a z is the array storing there are two elements, 10 and 11. Okay, here we start like 3000 and it is 3002. Now p is initially null here, and p is storing address of x. Suppose it's a 1000 here, and p is storing address of x here is a 1000, and like a personal address is like a 2000. Okay, now p is storing z1. So this is z0 z1 address of z1 in p. So yeah, it becomes 3002 here. It becomes 3002 here. Now what is the meaning is this? Star address of z0 plus 1 plus equals to 3. So here what is the z0 here? This is address of is 3000 here. Okay, 3000 here plus 1 address plus 3. Okay, this is the meaning of this one. So 3000 is 10 plus 1. Okay, 3000 onwards, skipping one element here, which is 3002. So this is 3002. Value on 3002 plus 3 is what here is a 14. It becomes 14. So it becomes 14 here. So what is the meaning of address of initial z0 element is 3000 plus 1. So 3000 is skipping one element. So next address is 3002. Value on 3002 is 10, 11 plus 3, 14 here. So 14 are updated here. Okay. So what is the x here? Okay. So okay. So it becomes in 10. Okay. This line, because p is storing address of x, and 10 is storing at this line is, you forget about this line. Okay, so 10 is storing the at the pp is what, 1000 is 1. So what is the x is 10 here? What is the z0? Z0 no change in z0, is it 10 only? What is the z1 is 14. So answer is a d, 10 10 14 here. So what is the answer here? 10 10 14. The d is the correct answer. D is the correct answer. Now next one is, what is the next problem here? Which one is it true? Option A, every subset of a recursive innumerable every subset of a recursive enumerable language is recursive. B, if a language L and its complement L bar are both recursive enumerable language. REL means recursive enumerable language. Then L must be recursive. L must be recursive. Okay. C complement of a CFL must be recursive. Okay. Okay, these are all are the gate problems. Okay, gate 2022 problems. If these L1 and L2 are regular, then L1 intersection L2 must be deterministic, context free. Okay, so let's see this one. Which one is a true here? Okay, which one is a true here? So let's see this one. Every subset of a recursive enumerable language is recursive. Okay, so subset of recursive enumerable language may be recursive or may not be recursive. It's a false statement. It's a false statement. Okay. No language is closed under subset operation. So subset of a recursive enumerable language. Subset of a recursive enumerable language may be or may not be recursive. May be or may not be recursive. So option A is false. It is false. B. If a language L and its complement L bar both are recursive enumerable language. Okay. So if a language L and its complement recursive, then L is recursive, yes, because complement are claused under the recursive only. Complement of recursive is recursive only. Or okay. So if L and complement is both are recursive enumerable, then definitely complement exists, or complement exists for which language is recursive. So B is the correct one. B is the correct one. Complement of a CFL is must be recursive. So let's see this one. So we can expand this language. Okay. So every CFL, so complement of CFL. So every CFL is CSL. Okay. Every CFL is CSL and every CSL complement of CSL is CSL because CSL is recursive language. So complement of recursive is recursive. So CSL. So correct one. So C B is correct one. So complement of CFL is recursive. Yes. Okay. Next one. Okay. So complement of CFL is recursive is true. Okay. D is what? If L1 is regular, if L1 is regular, L2 is regular, both are regular, then regular intersection regular is always regular. And every regular language is DCFL. Every regular language is DCFL. Every regular DCFL. D is also true. So B, C, D are true. So here option B true, C true, and D is also true. So B C multiple choices. B, C, D are true. B, C is true. Okay. Now next one is so next problem is what? This is one of the operating system problem here. Which one is true with respect to deadlock? With respect to deadlock here. So option A is circular weight is a necessary condition for the formation of deadlock. B, in a system where each resource has more than one instance, then a cycle in its wait for graph, resource allocation graph, wait for graph indicates the presence of deadlock. And C is what? If the current allocation of resources to processes leads the system to unsafe state, then deadlock will necessarily occur. And D, in the resource allocation, RAG means resource allocation graph of a system, if every edge is an assignment edge, then the system is not in deadlock state. Okay, so with respect to deadlock here. So here circular wait is a necessary condition for formation. Yes, there are 4 conditions are there. Mutual exclusion, hold and wait, no preemption, circular wait. Yes. B, in a system where each resource has more than one instances, then a cycle in wait for graph indicates presence of dead, not necessary. Okay, so if there are all of the resources are single instance type like that, this one. If all the resources are single instance, only means only one instance of resource. Then cycle, then we can say deadlock. If all the resources are single instance type and cycle, then we can say deadlock. But if are more than one instances, then we can't say through cycle is deadlock or not, because we are for if resources are more than one instance type, then we are using banker's algorithm to check deadlock will occur or not occur. So B is false. Now see what if the current allocation of a resource process leads to unsafe state, and deadlock is not necessary, because the unsafe state will not always lead to deadlock, because it depends on the behavior of the process. So it is false. Behavior of the process, it is not false. So it is false one. Okay, then not. And D. D is what? If every edge is assignment edge, then the system is not in deadlock state. Yes. If every edge is only allocation, it means there is no requirement of the resources. So deadlock not possible. Okay, every edge is assignment edge, allocation edge only. Okay. So D is the correct one. So every edge is a assignment edge means allocation. Allocation edge. Then the system is not in deadlock state. Okay. So D is the correct one. Now next one is this is one of the compiler problem. Consider the augmented grammar with a plus star open bracket closing bracket id as the set of terminals. So as grammar is given s plus r tends to okay. So if I0 set of two LR0 items, okay, it is given that if I0 is the set of two LR0 items, what two items here? This one as this s dot and s tends to s dot plus r, then go to closer I naught plus contains exactly how many items. Okay, so let's see this one. So here this is grammar is given I0 two items on which on s, okay, because there is a s moment is there, okay. Then exactly I0 plus on plus we have to check, we have to plus on. So here uh, let's see this. So here this augmented grammar s is a initial augmented grammar here. So all add all production of s here. After dot s is there, s tends to dot s plus r, s tends to dot r here, r tends to dot r star p, r tends to dot p, p tends to dot this one, p tends to dot id, okay, this one. So on s there are two items is what like s dash dot s dot here and s tends to s dot plus r here, okay, that's all. On plus, so on plus here what is this, we got to is s tends to s plus dot r. So after dot there is a variable here, so add all production of r here, also r tends to dot r star p, r tends to dot p here, p tends to this one and p tends to dot id. So how many items are there? 1, 2, 3, 4, 5. So what is the answer here? 5 items are there. Exactly 5 items. So just fill in the blank problem. So this is the fill in the blank problem. Next one is, what is the next one? Let's see this one. consider a simple undirected graph of 10 vertices. If the graph is disconnected, if the graph is disconnected, then the maximum number of edges, the maximum number of edges it can have is. So here, simple undirected graph of 10 vertices are there. 10 vertices are there. If the graph is disconnected, then maximum number of edges. Okay. So here, graph is disconnected is there. Then what will happen? It divides components. It divides in the components also. Okay. So let's see this one. Okay. So here, suppose the graph is disconnected here. So suppose that we are taking like this. Okay, like this. So how many vertices there are? 7 vertices are there, and k is a 2 here. 2 components are there, like one component, 2 components. Then what are you asking here? Like then maximum number of edges. So what is the maximum number of edges if there are graph is n vertices and k component n minus k into n minus k plus 1 by 2. So if we put it like this, so there are how many n in here? N 7 minus 2. 7 minus 2 plus 1 divided by 2 here. So 5 into 6 by 2. So 5 into here. So maximum number of edges can be, so E is less than equals to here. So max at most this number of edges are there. So maximum number of edges are like 5 into 6 by 2. Maximum will be 15. Okay, so in the problem it is given already 10 vertices are there. Okay, 10 vertices are there. Okay. Okay, and graph is disconnected. So there are, in the given problem there are 2 components are there. So here maximum number of edges formula is what? E equals to n minus k plus 1 by 2. Here number of components are given, there are 2. K2 is given here already. So this one is already discussed the mathematics, discrete mathematics lecture here. Okay, next one is so what is the next one? The number of arrangements, the number of arrangements of 6 identical balls, the number of arrangement of 6 identical balls in 3 identical bins is. Okay, so let's see this one. Okay, so number of arrangement. Okay, 6 identical balls and 3 identical balls here. So 6 there are 3 here. So there are 6 identical. So there are 3 identical bins. There are 6 0 0 yes maybe, and 5 1 0 here. It's a distribution problem only. Okay, next like okay, identical bins. Okay, so here 5 1 and 1 5 both are same. Okay, remember 4 2 0 here, 4 1 1 here. Next 3 3 0 here, 3 2 1 here, and 2 2. So there are how many? There are 7, because 6 identical balls are there and identical bins are there. So here 5 1 1 5 both are same. So no need to take like 1 5 0 here. So this how many? There are 7 arrangements are possible. Okay. Next one is the value of the following limit is the new math problem. the value of the following limit is. So limit x tends to 0 plus root x upon 1 minus e 2 root x. So here 1 upon, so here LS for the rule here, apply LS for 1 upon the root x and the differentiation 1 upon 2 root x equals to 1 minus, so here what is this here, minus e 2 root x into 2 upon 2 root x here. So here it is cancel out here. Okay, it is also cancel out here. So it becomes minus 1 upon 2 e 2 root. So through L-Hospital rule we can solve any problem like that. And x tends to 0 plus here. So what is this here? Minus 1 by 2. Okay. So 0 root 0 e raised to power 0 is 1, then minus 1, so minus 0.5. Okay. Next one is a very good problem, open system problem. It's a 2 marks problem. False one. So option A is that TLB performs an associative search in parallel. The TLB performs an associative search in parallel on all its valid entries. The PLB performs an associative search in parallel on all valid entries using page number of incoming virtual address. B. If the virtual address of a word given by CPU has a TLB hit, but the subsequent search for the word results in a cache miss, then the word will always be present in the main memory. Just wait here. Present in the main memory. Okay. And C is given like the memory access time using a given inverted page table is always same for all the incoming virtual addresses. Okay. So here, what is the first statement is there? First statement is there. The TLB performs an associative search in parallel on its valid entries using page number of incoming virtual addresses. Yes, it is true. The TLB performs parallelly search. It is asking about what which one is false here. Which one is false here? So it is a TLB performs an associative cache search in a parallel on its valid entries. Okay. So it is a false statement. So it is a true one. TLB performs an associative search in parallel on all valid entries using page number of incoming virtual address. Yes, correct one. B is what? If the TLB hit means. So what the TLB hit means? What will surely put in the main memory? Okay. So it is again it is true. Okay. So the word will always be put in the if TLB contains hit, then definitely the page will contain. Okay. Then the word means instruction always present in the memory. Yes. B is the true one. C what? The memory access time using a inverted page table is always same for all incoming virtual addresses. No. Memory access time using inverted page table is always not same. Okay, because there is no indexing applied here. Okay, no equally linear search here. So C is a false one. C is a false one. Okay, and D, what is the D here given? A system that uses has the page tables if two distinct virtual address V1 and V2 map to the same with high hashing, then the memory access time of these addresses will not be the same. Is it true one? Yes, it is also true. Is also the true statement is there.